Welcome to polyplane.com. Today we're going to be talking about the hierarchy of geometry. This includes points, curves, surfaces, and polysurfaces, or objects. At the very bottom of the hierarchy tree are points. Now for our purposes, a point is simply just an intersection in space. Namely, points can be used to define a shape, form, or point of connection on a surface or a form. Now if I were to extrude this point out into space, I would have created another point, and in between those two points would have to be a line. A line simply just connects two or more points. But we're not going to call this a line, we're going to call it a curve. It'll become more and more apparent as the video series goes on how important curves are to the construction of your final model. Now if we were to extrude that curve out into space and those 2 points on either side, we've created a surface. Furthermore, if we do that again and go into the third axis, or Z space, we'll have created an object. In this case, it would be a cube. So here in our Rhino environment, we have a point located right here. Now as you can see, this point is laying directly on our grid. There's a green line and a red line. From this view, the green line means the y-axis and the red means x. I don't want you to really worry about axes or C-planes or anything fancy like that just yet. Just bear with me because I want you to know where it is in space, because it's really important when you start to get into things like curves, surfaces, and polysurfaces. Here I have a series of curves so you can get an idea of what exactly a curve is in Rhino. Curve can mean a straight line, an arc. If you close it, you can start to make individual shapes. I can even turn on the points so you can see what those all look like. You can see how the points are referencing one another to create the shape. And in between each one of these points is an arc. Next up are surfaces. For our purposes, a surface is just a network of curves that is represented typically with some sort of topological boundary. So take this square for instance. If I turn on the points for it, you can see it has 4 reference points in the corners. And if I turn on the edges, you can see all of its edges are in place. And this clearly defines the topology. In this case, it's just a flat, 2-dimensional surface. It's laying right on the grid. But surfaces don't have to be flat. The main thing is they have to have a closed boundary. In this case, there's only one edge. However, it has 2 other curves that are defining its profile. So then in this case, you have a parabolic dish. One thing you can't do is create a surface out of a curve that's open. So say this arc, for example. If I wanted to turn this into a closed shape, if I type in planar SRF, you'll notice curve must be closed and planar. Well, in this case, it is planar, but it's not closed. You can't make a surface out of an open curve like this. You have to close it off. So I'll go ahead and do that. I'll just take those 2 points. So now, if I go over to my surface tools and select the second icon on the top from the left, you'll see surface from 2, 3, or 4 edge curves. I can click on the arc and I can click on the line, hit enter, and it'll create a surface. Now I can go ahead and make this cleaner by actually just joining the curves and typing planar surface, and it'll make a nice clean mesh. That's how you'd go from an open curve to a closed curve to a surface. Now you have all these surfaces, well, now what? You can actually take those surfaces and join them together and create all sorts of shapes. Here I have a few primitives. I have a pyramid, a cylinder, and a cube. And if you really look at these shapes, they're just a series of surfaces. So the cylinder is actually just a circle, a cylinder of one surface, and then it capped off with another circle. The cube is just 6 squares rotated in space. The pyramid, this is a 5-sided pyramid, is a pentagon and 5 triangles. So to review, a point is an intersection in space. Curve is connected by 2 or more points. A surface is topology that's defined by at least one closed curve. And polysurfaces are just a bunch of surfaces that are connected together. Thanks for watching and have a great day.